This video is over chapter 10 and I'm going to work through example 93. When you look at the notes, I gave this example. I said let f of x be this function, x squared minus 1 quantity cubed plus the square root of x squared minus 2. And I asked you to find functions h and g such that g composed with h is equal to f. And I simply said that there were several solutions. And actually I didn't say anything, but there are literally infinitely many solutions to this problem. Parts A and B are a little bit cheating, and I'll explain why that is in a moment. But in part A, we just let h of x be the function itself. And then we let g be the identity function. So g of u is equal to u. And so then when we compose g with h, what happens? Or when we have g of h of x, well, h of x is f of x. So that's the same as g of f of x. But what does g do? It's the identity function, so g of f of x is just f of x. So that is one very cheap, easy solution. You simply let h be f of x. The other cheap, easy solution is to let g of u be f of u. So g is essentially equal to it. So g is equal to f. And then h of x is the identity function. And so when we look at g of h of x, what does h do? Well, really nothing. So g of h of x is just g of x, which is f of x. So these two solutions are correct, but they're not very useful. C and D are a little bit more useful. What do I mean by that? Well, the reason we are looking at this exercise is when we get to the chain rule, we're going to talk about calculating the derivatives of the composition of two functions. In order to do that, we need to be able to recognize our function as a composition of two functions. So that's what this exercise is about. A and B are technically correct solutions, but they're not very useful solutions. So C and D are better. For C, we're going to let h of x be x squared minus 2. Notice we have the x squared minus 2 right here. What is the relationship between x squared minus 1 and x squared minus 2? Well, if you take x squared minus 2 and add 1 to it, you have x squared minus 1. So if h is going to be x squared minus 2, what is g going to do? Well, it's going to add 1 to that and then cube it, because we have x squared minus 1, which is x squared minus 2 plus 1 cubed. And then g is just going to take the square root of u right here and add those together. So when you look at g of h of x, what happens? H of x is x squared minus 2, so we have g of x squared minus 2. What does g do? Well, it's going to take the x squared minus 2, add 1 to it, then cube that term. Then it's going to take the square root of x squared minus 2, and finally add these two together. So we see that g of h of x is in fact f of x. For the fourth solution, we notice that we have an x squared minus 1 term as part of our f. So we will let h of x be x squared minus 1. So what does g need to do to x squared minus 1? Well, first of all, it cubes it. Then it subtracts 1 and takes the square root. So if h is x squared minus 1, as we let it be here for solution D, then g is going to be u cubed plus the square root of u minus 1. So we verify what is g of h of x. It's g of x squared minus 1. What is g of x squared minus 1? Well, we cubed u, so we cube x squared minus 1. Then we subtract 1 from it and take the square root. And so we verify that g of h of x is in fact f of x.